So we're going to continue section 3.7 that we started last week about related rates, and we're going to look at the following problem. We're told that an airplane is flying on a flight path that will take it directly over a radar tracking station as shown. There'll be a picture in a little bit. I'm told that the distance S is decreasing at a rate of 400 miles per hour when S equals 10 miles. What is the speed of the plane? So here's my picture that I'm given in this problem. There's my plane, there's my radar station, and I have my label S and my label X. So remember what we do with these problems is we write down what we're given. So what are we given here in this problem? Which rate? If I look back, I'm given S, the distance S is decreasing. S is decreasing at a rate of 400 miles an hour when S equals 10. So what I'm given is I'm given ds dt. And because it's decreasing, it's going to be negative 400 miles per hour when S equals 10. Now I need to identify an equation here. So if I go back to my picture, I'll see that this triangle, it's a right triangle, and so I can use the Pythagorean theorem here. I get x squared plus 6 squared equals s squared. So there's my equation. X squared plus 6 squared equals s squared. And what am I asked to find? Let's go back and read our question. What is the speed of the plane? So I'm asked to find what is the speed of the plane. Well, the plane is traveling along that x, so I need to find dx dt. When s equals 10. So I've got what I've broken everything down into what I'm given, my equation, what I need to find. So now I'm going to take my equation, which is x squared plus 6 squared is 36 equals s squared, and I'm going to take the derivative of both sides using implicit differentiation. I get 2x dx dt equals 2s ds dt. And I'm supposed to find dx dt, so I want to solve for that. Dx dt will be 2s over 2x, and then you can cancel these 2's here, so you'll get dx dt equals s over x ds dt. Now I have to know all these values on the right hand side. So do I know ds dt? Yes, that's what I was given. And I also know s, but I've got a little bit of a problem here. I don't know x. So to figure out x, you're going to go back to your equation up here, and you're going to plug in s equals 10 into this equation right here to figure out x. 10 squared is 100, so x squared will be, if I solve for x squared, it'd be 64, so x is going to be 8 miles. So now I know my value of x, so I can plug everything in and solve for dx dt. So dx dt will be s was 10, x was 8. We just solve for it. And ds dt is negative 400. So dx dt would be negative 500. And we need units, remember? It's going to be miles per hour here. And so what is the speed of the plane going to be? The speed of the plane is 500 miles per hour. So there's my answer. And it makes sense that we got a negative answer here, because if you go back and look at our picture, the plane is flying towards the radar tower, and so that distance, the measurement here, x, is going to get smaller because the plane is moving towards the radar tower, so dx dt should be negative. Okay, so there, again, our answer was 500 miles per hour for the speed of the plane.